lesson in Unit 5. We are doing 5.10 linear and nonlinear tables. Linear. Now we went over this earlier in the unit. This is the end of the unit. So what does linear mean? It means what?
Straight.
The graph is what?
Straight.
It is. The graph is a straight line. So obviously then, what is nonlinear? The graph is not a straight line. Easy as that. Linear, nonlinear. Looking at these graphs, it says identify if the function is linear or nonlinear and explain your answer. So A, circle. Raise your hand. Who thinks linear? Who says nonlinear? Yay, we all know our straight lines from non-straight lines. So it is nonlinear. And why?
It's not a straight line.
Not a straight line. That is about how easy this gets. Not a straight line. How about B then? What is that? Obviously linear. Why? Straight line. Don't you wish math was always this easy?
Yes.
No, it would be boring. I agree. Good answer. How about C? Now they give us an equation. Y equals 1 over x. Y equals 1 over x. So that's kind of like plus 0. So what is, I put my plus 0 if it was there. What is 0? 0 is your, it's your y-intercept. Now, it's 1 over x. It's not 1x. Is that going to make a linear or a nonlinear? That is going to make a non-linear line. It's not in y equals mx plus b form. Because here you're going to have to divide 1 divided by x. We don't do that when it's in y equals mx plus b form. We take it times the x, our slope. Here they're going to have something divided by x. It's not in slope-intercept form, so it is nonlinear. How about D? This one we knew. This was kind of a bonus on one of our quizzes. Linear or nonlinear? Nonlinear, and we just talked about this. Why not? X has an exponent. Oh, we forgot to or justify our answer here too. What did we say then? Why is this one nonlinear? It's not, you could write either one or both. Not in y-intercept form, not in slope-intercept form. Or you could also put because you have to divide x by 1. And there's no dividing allowed in the slope-intercept form. How about E? Looking at this table. Looking at that table. Linear or nonlinear? Let's vote. Who says nonlinear? Who says linear? How can we figure it out by looking at the table? What are we going to have to do?
Go down the y or whatever and see what you get to go down to the other one.
Okay, so you want to go down? Let's go down. What do we do? A -2 to a -1 is doing what? +1? -1, does it work for all of them? +1. And they're going in order, aren't they? -2, -1, 0, 1, 2. That one works. That's in order. So far it looks linear. How about on this side? What do we do here? What's the pattern? Here it looks like I had to plus what? Think money. 0.25. So 50 plus 0.25, is that 1? No, because here I added 0.5,
maybe like 1,
here I added 1,
2.
here I added 2. So does that have a pattern on that side? So no, so that is non-linear because they didn't do the same thing. The ratios of the inputs to outputs is not the same. The ratio to the input to the output is not the same. Okay, and F. Linear or non-linear? Who says linear? This is non-linear. Ooh, we're still awake. Everybody got that one right? And that's an easy one. Justify your answer. Why not? Not straight. Easy as that. Questions on those four? Alright, let's go to this page. We have G and H. G and H. So I'm going to give you a couple seconds to figure out what the patterns are on both sides to see. Is it linear or non-linear? So what did you come up with for letter G? Linear or non-linear? You're telling me non-linear. Why?
Ratios to the inputs is always the same.
The ratios of inputs to outputs aren't always the same. What does that mean? What was our pattern here, Mikesha? What did you get for your pattern on this side? Okay, +1, and that worked for all of them on this side of +1, but here they did what? They +3, and then here they +1, +1, +3. So they didn't have the same pattern on the Y, on the output. So your ratio of your, remember, this is on your quiz and your test, these are your inputs, these are your outputs. What's another name for an input? We talked about this yesterday. What's another name for an input? The X is your input or your, starts with a D. Your what? Domain. That's another word for outputs. Your range. Okay? How about H? Linear or non-linear? Linear or non-linear? Who says linear? That's what it should be. Why? Your ratios are all the same. Because what did we do here? We did +3 to everything. Here we did a +1. So our ratios are 3 to 1, 3 to 1. Over here they're 1 to 3, 1 to 1, 1 to 1, 1 to 3. They're different. The ratios are different. Here your ratios are all the same. All right, example number 2. Create an example of a nonlinear function using each representation. Give me some examples. Anybody want to give me an example of a nonlinear, what we just did? What's that? Remember slope-intercept form, please. X squared plus 1. That's simple. That one works. It's perfect. Anybody want to give me another one? Y equals Here, let's use the same thing, but still make it different. So how can I add y equals
X2.
x to the third power, x cubed plus 1. Another example of nonlinear. Okay, on the graph, this takes us back to, I think, like our first lesson in Unit 5. We could draw a nonlinear like that. We could draw a nonlinear, remember the graph? Then we have the, like this. What was another one we had? Which one? The scatter plot one. And they were just randomly all over the place. And there was actually one more.
That
The V. Yep, those are all nonlinear examples that we talked about earlier. How about in a table of values, a nonlinear? If I went -1, 0, 1, and 2, what pattern do you want to use here? What pattern did I use here? What did I do to make that pattern?
You just added one.
I did. I just plus 1 to get 0, plus 1 to get 1. So my pattern here is a 1 every time. What do you want to do over here? Make it nonlinear. What should we do to the first one? Say I have a, let's go with a 4 here first. What do you want to do to that 4? You want to go by, instead of going by adding 1, adding 1, adding 1, what could we do? We could add 1 and get, or let's go with 2. What's 4 plus 2? And I could get 6. Let's go, yep, exactly. Plus 4 then. What's 6 plus 4? 10. So what would be my next one?
That would be too high.
So what is 10 plus 6? And so on. You could just keep going. So that would be an example of a nonlinear because the ratios are not always the same. Example 3, this is the last one of our notes for Unit 5. Graph each nonlinear function. All right, well, you graph it the same way as what you know how to do your other ones. What's the best thing to do?
X and Y axis.
Okay, well, we could make a table. Like, I think that's what you meant, your X and your Y. Make your table. What is my y-intercept here? Y equals x squared. What's my y-intercept? What is it? What's my y-intercept? It is, it's 0, because it's like plus 0. So we know we're starting here at the 0. Now what do you want to use for some numbers to graph? Let's go -1, 0, 1, 2, and -2. Let's use those. What do our answers come up with? So if I put a negative one, I'm going to write this bigger. Y equals the x squared. What if I have a -1? What is a -1 squared?
-1. No, positive.
What is a -1 squared? What do you get?
It would be positive.
You would get a positive 1. Right? -1 squared is a positive 1. So what do I get for 0 squared?
0.
Well, 1 squared. 2 squared.
4.
And a -2 squared. 4 again. All right, let's plot those now because we have to graph it. So negative 1 and 1, 0, 0, 1 and 1, 2 and 4, negative 2 and 4. What are we making there? Does it have a curve or is it straight lines?
Straight.
That one's a little bit, it's kind of a curvy B, but yep, it's got a little bit of a curve to it. How about B? Now this is Y equals the absolute value of X. And then they don't write plus 0, so we know we're going to be starting at our origin again. Absolute value. So let's make our T-chart. X, Y. Let's use negative 3, negative 2, negative 1, 0, 1, 2, and 3, please. That way we have plenty of points. I'll give you a couple seconds to fill those out and graph them. If you're watching the video, stop the video here and graph it and then restart it. Right? Because if you remember absolute value, that basically means how far away from the 0 on the number line are you. So if I have the absolute value of 3, well, that means 3. I am 3 units away from 0 on the number line. How about what's the absolute value of a negative 3? That also is 3 because I'm also 3 units away from 0 on the number line. So if I look here, then the absolute value of a negative 3 is 3. What's the absolute value of a negative 2? Negative 1, 0, 1, 2,
2,
3.
3.
There you have it. So now you graph those. You start at the origin, 0, 0, negative 3 and 3. Negative 2 and 2. Negative 1 and, oops, I'm on the right, am I on the right one? Negative 1 and 1. Yep, there we go. 0, 0, and then going this way. This one makes a nice straight line though, doesn't it? This one was kind of curvy. This one makes a straight line. So is it linear or non-linear? Don't let me trick you. Is it linear or non-linear? That is non-linear. Even though these make nice straight lines, it's continued this way. It's not linear. It is non-linear. And the very last one, let's do, okay, we have Y equals X cubed plus 5. Let's use the points. Let's do, because negative 3 won't fit on the graph. That goes way off the graph, but now we'll do it and kind of guesstimate where it's at. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. So what do I get here? I know some of you, when we had the video stopped, worked ahead. So what is negative 3 cubed? And if you have 3 negative, that's an odd number. Are you going to have an odd or an even, or excuse me, a positive or a negative number?
Negative.
You're going to have a negative what? What's 3 times 3 times 3?
18.
3 times 3 is 9. 9 times 3 is 27. So you're going to have a negative 27, but then we have to plus 5. What's a negative 27 plus 5? A negative 22. All right, let's go here. What's a negative? Now instead of a negative 27, we have to come up with what's a negative 2 times a negative 2 times a negative 2. Negative times a negative is a negative. It's odd number, so it's negative what? 2 times 2 is?
4.
Times 2?
8.
8. Negative 8 plus 5 is? Fight. Who wins? Negative by 3. What's a negative 1 times a negative 1 times a negative 1?
Negative 1.
It still is a negative 1. What's a negative 1 plus 5? We end up with 4. What's 0 plus 5? 0 plus 5, not times 5.
5.
5. What is 1 times 1 times 1?
1.
1 plus 5 is 6. And we said instead of a 2 times 2 is 4 times 2 is 8. Now it's a positive 8 plus 5 is, what's 8 plus 5? 13, and this one will be 32. Plot those, 0 and 5. I can go -1 and 4. I can go 1 and 6. Oops, 1 and 5. That should have been, no, 2 and 6, that's right. That one should be 2 and 6. Right here, so I did the 2 and the 6. Oops, I got my 0 and 5, 1 and 6. I did do it right the first time. Can't read my own writing. One, there we go. 1 and 6. And then what do I have down here? The 13 doesn't really fit on there, but we can kind of guesstimate. Here's 10, 11, 12, 13. I could maybe put that about up here. -2, -3 fits on there. Down here. -1, -4. Does that fit on there? Oh no, that's a +4, isn't it? That one was up here. Which one am I missing? Is there any others? We can kind of guess. -3, -22. That's going to be way down here. Be down here somewhere. So if you kind of connect your lines by your guesstimates, it's going to be something like that. Infinity and beyond. Non-linear. All right, your assignments, the last pages of your packet, 9 and 10, due tomorrow.